In the middle of the night, there is still sunshine. It looks just about like that at midnight when it's cloudy. And you would think that's like a solar punk paradise, right? There is sun all the time in summer. But solar punk is largely based on transparency. And when I think about transparency, that brings me closer to an environment which is more like a desert. Something where you can see everywhere, you can't hide. Everything is out and open, bare under the overseeing sun. And that is far away from how it looks in a Nordic environment. Because one of the very important elements in the life of the people up north is the forest. And the forest provides them with comfort and also with the resources. You know, you can live pretty autonomously in a decentralized way, do your fishing, hunting, or collect berries, collect mushrooms if you wish, if you don't want to hunt or fish, and hide from that sun, which is 24/7. And that brings us closer to more like a lunar punk lifestyle, or philosophy if you wish. I'll be talking about these concepts a little bit more in today's evening in a block up here, in a panel. So if you're interested, please come at, I believe it's 8:30 p.m. We will be sharing panel on anonymity and privacy and how that's important for decentralized communities. But when I'm talking about that and how it connects to the privacy on Ethereum is that Ethereum is solarpunk. It is based on the transparency, on a full transparency, on a chain level and on a network level. And tonight, I'm sure we'll be talking about whether it's good or not for a brighter future or darker future, if you wish, to have fully transparent user operations such as transactions, staking, voting, and all that stuff. Many would disagree with me that perhaps that's the way to go, which I don't believe so. But today I would like to focus more on network level. And I would argue that whether we disagree on a privacy, on transactions and votes and what have you, on a network level, the full privacy is in fact dangerous for Ethereum itself, as it prevents the full decentralization which Ethereum is supposedly based on. And I believe that's our common aim, whatever we think on about privacy on a transaction level. Oh, too many computers. So today I will plant some of the seeds of the forest I brought with me from the far up north. And we'll be talking about some of these issues and see how we can take some of these seeds, plant some of these forests and make this lushy vegetation so we can actually all together live happily under that sun. And what does that mean not only on lunar punk philosophy, which we'll be talking later about, but particularly about what does it mean on a level of tech, and brought by NIM. What does it mean for Ethereum? I'm Serinko. Thank you all for coming. I see it's still filling up, so those who came later, welcome again on Privacy for Ethereum Validators talk. I'm a new, fresh member in a NIM core team, working on developer relations. Besides that, as a community member, I'm helping LunarDAO with some privacy research as well. LunarDAO is the first LunarPunk DAO, so check it out. Prior to that, I was working in DarkFi, which is a native layer for anonymity engineering, very important project. Make sure you check both of them out. Why I'm interested in these solutions is because history teaches us that if we want to have autonomous, free, and decentralized communities, that is not going to happen without anonymity and privacy. However, that's in opposition how ETH is designed today. And that's the point which I'm going to try to drive home during this talk. Let's begin with the internet, which is broken. And when I say broken, it's not like it was good and then it got broken yesterday. No, it's broken by the core design. What I mean by that is that on a network level, right now, there is this big overseer, these powers with endless computing energy, which can basically watch and monitor whatever's happening in network level. I'm talking metadata here. I'm talking about things like end-to-end encryption, such Signal, Zcash, or Monero are still having metadata leaks if you watch it on a network level. VPNs are not really bringing anonymity. It's just a centralized trust being moved somewhere else. Neither Tor anymore if the adversaries are as big as NSA or private companies. And the same is on ETH with chain analysis. Our solution is to create a default privacy layer for all internet traffic. That, to be particular, means to create a mixnet. Mixnet is similar to Tor. Is any of you familiar with Tor and how it works? Wow, many. Wow, this is going to be technical talk. You're going to grind me down during the Q&A. I'll try to speak as long as possible so you can't have any questions. Great. Tor has multiple hops, and Mixnet works similar like that, but we have few more tricks in our sleeves to add to defend against a time correlation attack. One of them is a covered traffic. That means that there is a dummy packages being given to the being added to the traffic, and all the packages are being broken into same size data packets when you're sending them to the mixnet. On top of that, there is a time obfuscation, so you have all the data packs being mixed together with another user's packets and with the dummy packets as well. They all take different routing, and on each of those hops, there is a different timing at it, or a latency. And that all is in a horizontal scalability, so not like Ethereum constantly facing the problem of scalability, because this is a mixnet. Maybe I move to the next slide. You have hops which are waiting to be part of an active set once there is a bigger traffic. If we compare to VPN down here, we can basically see the time and the size of the packets, or the volume of your data traffic is just going to another IP address somewhere else. You're giving them the trust. They have complete control of your traffic, and then you send it to the internet. Tor is doing much nicer, bring in some hops. There's the onion routing, but the volume and the time is still the same. So if you have a capacity to be watching over a large portion of a network, you can do two-sided correlation attack, or disclosure attack as it's also called, and watch on the volume which is coming in and the time, and correlate it with the volume and time coming out. And by that you can get a pretty solid estimation what and whose data we're talking about. While if you look at Mixnet, you're sending the data which gets broken into the packets I was talking about, and they go fully anonymized, all same size, flip timing out to the internet. If you would do a little deep dive, all that's happening on your client and your machine, and then the packet system which we talk about is called Sphinx. Sphinx packets are those same packets with the dummy packets added being sent through the Mixnet, and each of those is taken different route before it gets to the service provider, application, or internet in general. What does that mean for Ethereum? How many of you runs an ETH2 validator? There's very few hands here. I think it's like, oh, we go live stream, I'm gonna stay anonymous, right? But my point is that you're not, right? Like, even if you don't raise your hand, that's not gonna protect much. But good, we have few in the room. I might not, I don't know. Ethereum validators and how it works. We can go very quickly over that, but I think there are more educated people on ETH itself than myself, but basically you have the beacon chain, you have separated consensus and execution, there is the coordination algorithm, which chooses the next validator through gossiping, and then one validator gets picked, that validator gets the block, signs the block, gets the rewards. There are some niche things being made on the terms of security on Ethereum too, and that's separated the validator identity from the network identity. However, Ethereum researchers had shown us that it's easy to connect the two by basically looking at a batch of rewards. And because the algorithm is fundamentally deterministic, you can predict which validator will be doing the next block. You can DDoS that validator and knock them offline. That's one of few issues which are happening with a fully transparent network level. Another one is that because everything's out there, the IP addresses, which means geographic locations, which basically means your address, where you live, is also to be collected on the internet. And together with the timing, it can be used to deduce which validator is which. There was this big scandal when on crypto Twitter it came out that possibly some people from ETH Foundation might collect all of these addresses, which is leading to a second issue, and that's a validator censorship. If you happen to live somewhere which for some reason people find it's a location which is not really suitable for running the traffic, or because there will be some governmental embargo and they will want to play nice ones, you basically can be just censored out of the consensus, and you're not going to get any rewards because you're not going to get any blocks. And then the validator attack through DDoS attack on validators, which I was talking about. It hasn't happened yet to my knowledge, unless somebody is informed otherwise. But I would say the stakes are quite high for such a vulnerability to exist in the first place. So with these issues and trying to connect the mixednet privacy on a network layer I was talking about with Ethereum, we're looking for solutions in NIM. And we have a libp2p integration. There is dev-p2p, libp2p. We have chosen libp2p because it has some more stack to build upon. The integration is built together with ChainSafe, jointly with ChainSafe. You can go up to the GitHub and see the integration. You can check it out, play with that. It's easy to use. Basically, on top of libp2p, it's called Trade, and you can just natively use NIM. You are kept away from the NIM complexity I was just talking about. You basically plug libp2p, turn it on, and run libp2p, which NIM is integrated on top of that as a pluggable transport. So you don't have to worry about all the NIM stack sides of that. It's fully written in Rust. I see few Rust people in here. So you are welcome to try it, test it, implement it. And you don't only get transport layer guarantees, but you also get full mixednet privacy guarantees thanks to NIM. I'm sorry, I'm shuffling here between two computers. Not used to use somebody else's computer. Anyway, if we dive a little bit closer, basically what we did, we abstract away the complexity of NIM and make the abstract connection to implement on top of libp2p. And there is a full spec as well. You can go to this HackMD and check out full spec. Big shout out to Elizabeth, who did a lot of work for that. But as you can imagine, it wasn't so easy. Even though NIM is by large in Rust and libp2p is in Rust, when you plug the two together, quite few things weren't working well. Especially the thing when you dial to do gossiping, you need to open a connection. And to open connection, you need NIM address. And then NIM doesn't guarantee message ordering, right? that's not a bug. That's the feature I was talking about, because NIM mixes all the packets and all the timing, so we don't have no ordering. But how is that gonna work? So sending mixed packets through the mixnet while needing a message ordering, we added nonce to have a counter and hide the addressing with 32 bits encryption as an identifier. And these changes allow us to run multiple data streams. It's called streaming mutex on top of like P2P. And one of these ones is NIM. This brings us, of course, to the question on which validator to run. How we gonna do that through the validator side of things? We have chosen Lighthouse integration. Anyone here runs a Lighthouse? No? It's ETH2 validator software stack for consensus. These are the, too many screens. These are the tutorial how to go through that, the instructions. It is now in a kind of like a beta version, so keep with us. It keeps being developed. But more than that, it brings an important question, and that is, will it be fast enough? Because what is producing blocks on ETH all about? It's all about speed. It's all about making them in time. It's about the race, the competition of the speed. So whenever we add an anonymity layer on top of that, the question comes, will it work? Will it slow down the process? Or the process is not going to get slowed down, so a better question would be, will Mixnet work in its full functionality to fit within the process which is existing? We get some stats here from Lodestar, and total time for block production is 4 seconds, according to these stats from Lodestar. We can break it down to what does that mean? We need 300 milliseconds to produce a block, at 1250 milliseconds to open a slot to receive block from network, and on top of that 550 milliseconds to process block. That leaves us with something like 2.1 seconds. So the question comes, is it enough time for NIM Mixnet to plug in and work the way it's supposed to? The answer is yes. Right now, with counting this to 2.1 seconds, NIM Mixnet speed is about 300 to 400 milliseconds. Let's be on the upper edge of 400 milliseconds. There is still a spare time to mix more. Also, we're working on having users, or like on client side, choosing way how much you want to mix. If you want more anonymity, it's going to take more time, or you do less mixing for speed. So you can basically like dial up how much you want to be doing the mixing, but in its current state, this is fast enough. On top of that, because we are working together with Daniel Bernstein, who works on Curve 25519 and works on a Sphinx packets format upgrades, we're gonna get probably 2 to 4 times faster. There'll be more updates coming on that, but basically in cryptographical language, if any of you is a cryptograph here, it means removing one of the Diffie-Hellmans from the curve. So I want to once again give a shout out to Elizabeth and to ChainSave, who did a massive work on that, and bring us to what are the next steps, what's coming down the road. I don't know if any of you is following him, but we just announced a privacy cutting edge partnership with Aztec. I believe people are familiar with Aztec. And that's to address few issues. I broke that particularly into 2, which one is scaling issues of privacy blockchains. Prior to that, Aztec was running Aztec Connect, and they were using trial decryption to overcome this, and that involved to download both global private and public chain data. But there was basically an extensive database growing, and it was not sufficient and stable to run that, so Aztec Connect closed down. On the other side, we have privacy leak in the public state chains, such as on ETH. And that does not require encryption because there are no pre-images visible. And it contains all the commitments and hashes. But then that has a problem that obviously data are leaked. So bad actors who are a bit more sophisticated can triangulate who owns what part of the state and connect it together with the network data, and we are back in the same problem I've been talking about in the beginning. So the solution we bring in is on Aztec side, as they call it, the first of its kind hybrid ZK rollup, supporting both public and private smart contract execution called Aztec. So both the project and the product is called Aztec, running through Mixnet. That will bring a few solutions. One is the NIM Mixnet, as it's shown, will protect the public state. It'll be routing through the NIM Mixnet, and all the information which can identify you, such as the IP address, and the location connected to that will be obscured because the server only receives the anonymous requests, which is only a portion of the data disconnected from all the rest. The rest remains separate and encrypted, so there is not all the data being all transparent on the internet, on the network. And that brings privacy by default on the network level on Ethereum when we gonna do this joint collaboration with Aztec. Here, if anyone wants to scan that, there is a full announcement of the partnership with Aztec, or you can just find it on a blog, which is blog.nimtech.net. Okay, I see a few cameras up. To close down, I want once again thank you, Elizabeth, who did very heavy lifting for the lib P2P integration and for the spec. And close down with a sentence we've also used in partnership with Aztec, which is with the right combination of technology and commitment to user-centric privacy, we can build more secure and confidential and decentralized future together. Thank you very much. Well, questions?
You talked about the latency implications of using a mixed net. Are there bandwidth implications with the cover traffic or anything else that adding, like using a mixed net would add to someone? Like how much additional bandwidth do you have in the process of using a mixed net? Say, for instance, in Ethereum.
So for Ethereum, the thing I was showing is working. The bandwidth is a problem. NIM is not running now on a full internet, like full system-wide scale. How it works right now, the main thing is called NIM Connect, and you basically can use NIM Connect to connect to different system providers, applications, or what have you. And NIM Connect has different clients. That there is WebAssembly, WebSocket, and SOX5, which is now the most promoted and the most used, because through that you can build very easy integrations. We were just presenting 2 weeks ago one for Monero, so the whole Monero can run on a mixnet. On a chatting side of things, we now published a new one on Element for metrics, or Telegram and what have you, but so far it's based on single particular integrations for different network providers. We are working on a system-wide, whole network level, like entire internet setup, which I don't want to say hope, we aim to have by the end of this year. Like an alternative to a VPN, which you just turn on and all your traffic is running through the mixnet. But right now, there is between 550 to 600 nodes, and you have them always in those 3 hops, where each node is in that's randomized. So you can imagine that there is like a limit to that. You cannot like have a video calls or something. But with more usage, there'll be more nodes because they're also incentivized through the token. And meanwhile, building a solution which can work on a system-wide level, I believe will bring this bandwidth and the answer to in like higher scale.
Thank you.
Can you explain a little bit more on the incentive system? Because like if I'm a government and it pays me to run all the nodes, I mean everyone's always said Tor is just ran by the CIA, so or NSA. Like what's stopping them from just becoming NIM billionaires or just not running at a loss?
Well, you gotta presume that you're starting in fully non-compromised position, right? Because once you do, then we are screwed. Because anything after that is gonna be a problem. So there is few features which many don't like or have critiques. I think for good reasons. And then there is always like, how are we gonna solve these questions? And this is one of them. So NIM didn't start in a way that there would be like an offer to run a node just for anyone. It started by people who are somewhat connected to the core team, and then based on trust, more mixed nodes were starting. Now anyone can spin up a mixed node. But there is, one of the incentives is that there is a delegation. And it's hard to imagine that some people who were starting NIM would just be delegating to NSA nodes which just appear. NSA can spin up a lot of nodes and they can delegate to each other, they can buy the token, but what is hard for them to mitigate is when you watch it, when you look on it on a network how it works, there is something called like organic social networking. And it's quite difficult for them to play like they are like a social organic actors within, within the crypto waters. I can go deeper on how it's made on an incentive level. Basically, you have a NIM supply of a NIM token. There is a token running on Nix chain. Nix chain is on Cosmos because it's faster than Ethereum. And from the complete supply, it's expected to have half of it locked in the mixed nodes. Because basically, when you're spinning your mixed node, you bond some of NIM tokens to the mixed node. Then more you're mixing, more rewards you're gonna get for the users who are gonna pay for that. That's the second thing which people don't like so much, that it's not gonna be free completely. It is now, it's running for free, and it's probably gonna till several months or till the end of this year, so you get an opportunity to run NIM Connect completely for free. But if you look on Tor, how many nodes are running, how many relays, you see that few times the number spiked with some like bad news when something happened. Same like, like on the other hand, like Signal is growing, the users are growing, like post-Trump, the Signal users went like this, then WhatsApp got sold and Signal users went like this again. But the Tor nodes, now when you can run so many crypto, different nodes, validators, mining, what have you, and you're gonna get rewarded for that. It's very few enthusiasts who like the number went like that, and now the Tor nodes is pretty flat. So NIM had decided, okay, we're gonna run incentive. The users can pay for that. Doesn't have to be the users, can be the service providers, right? They can buy bandwidth for the users of their service or their application. And then the people mixing, providing the mixed node, they're gonna get the rewards. So then the tokenomics are made in a way that you have expected to have half of the supply locked in a mixed nodes, which gives us some number of tokens. And this number you divide in between the active set of mixed nodes. That gives you some number, what is expected to be on one mixed node bond tokens. They can be bonded by the operator themselves, or they can be delegated from other people from the network. And that closer you get to the number, which is called a stake saturation, the better chances and the better rewards you're gonna have. But there is also a prevention of centralization, prevention of whales, because if you're gonna start to be above that number, you're also not gonna have a perfect algorithm for your rewards. So we wanna try to get as many people. Right now I think it's about 720,000 NIM. The price is about 20 cents, 18 cents, something like that. So closer you get to 720,000, the higher chances of getting rewards you're gonna have. If you're gonna have less, you're gonna have less chances. If you're gonna have more, you're also gonna have less chances. That's how maybe I give a little bit too much information, but that's how the algorithm, how the incentive is working. All right, you can check more out on nimtech.net or just find me around here. I'll be downstairs. We're giving some swag, and with all the interesting presentations coming after me, also at 8:30, there will be a panel on anonymity and privacy, importance for decentralization of communities. Thank you very much again.